Why the sharing of digital information is impossible. This video is a look at computer technology that restricts our ability to share information. Before I start, I'd like to cover a few small items to get you in line here. Sharing of information is technically extremely possible, just not with our current technology. Not having the ability to use the information limits knowledgeable actions. Means that if I can't have access to somebody else's information, then I can't do anything with it. And even if I do get it, is that information, which is really the sharing ability, you can give it to me, but if I can't use it, then it does me no good. So is that structure in common? Can it be used by common logic? Can that be applied? So everything now is in uncommon structures. So yes, you can give me a Word document. Fine, you can tell me every bit and byte in there, but it does me no good unless I have to rewrite Word. So we're not getting anywhere. The sharing of information, logic, and knowledge is required for progress in all technologies. So if you're in mathematics, we basically can't share math equations. So we can't progress in mathematics if we're using a computer for mathematics. And if we're doing physics or dance or music or chemistry or molecule design, we have to be able to share that information. I'll get into what I mean by sharing here in a few minutes. This is just some basic stuff. Greed. Okay, before we start, we should look at greed, which is where we're at now. So companies, software companies will say you or anybody else must use my product to access the information you create. So this works for every product out there. Word, you have to use Word to access a Word document. Excel, AutoCAD, Oracle, databases. Everybody has their own application that's out there feeding you information, and if you do create it in let's say Oracle, then the only way to get that information out is through Oracle. So why is sharing information impossible? Well, first, no two applications can process information the same in our current technology. So we can look at HTML. Here's some information we can all access, we can all read it, but we can't process it. It's pretty much a proprietary application-dependent structure. Okay? Only Chromium and a few other little products really no two applications can create logic identically. And the way they keep changing HTML and keep making all kinds of customized personal preference logic modifications, no two products are ever going to reproduce HTML the same. Not until we change HTML. But this is one of the reasons it is impossible to share information, even things that we think we're sharing. We only have one browser to access all information on the internet, and it only has one purpose. Okay, proprietary data structures. This is intentional. Nothing is really open. Go to any company and say, what is your structure of your information? And they will not tell you. But you still have to write the logic to use it. So it's really not shareable. Our compilers, our operating system, and hardware dependencies restrict shareability. It means that you have to have that compiler or that operating system or that hardware to actually run and access information in an identical way. Binary structures are different. Conventions are different. Compilers are different. I once downloaded USGS projection algorithms, and they had published them in two different formats, one in Fortran and one in C. for all their projections, state plan, UTM, and so on, Mercator projection, Lambert projections. And they also gave a tape of all the test cases. They did a 1 degree grid around the Earth and did all those projections and all these different state plane and so on projections. And so I ran them. I compiled them in Fortran and I compiled them in C. And the ones in C ran perfectly. The ones in Fortran did not. So even though the information was identical, the process was written by the same person, there was a 1-bit difference, and so I had to go in and make sure I could modify that. And that's the issue with information is trustability, and can we really share that information and realize what is actually happening in our information logic sharing. So right now we have billions of isolated applications. We have so everything we do is in this process and then manually go to the next process. So we have an editor, so we create a Hello World application. Then we have to compile that, so we go into the compiler and we compile that to, let's say, an object or an emulator. And then we have to go to the linker and link it up to other object modules. And then we have to load that into the executable to run it and test it. And then we have to install it. And that's another scripting language that we have to use to do that. Then we have to distribute yet another subsystem and different logic and different scripting languages. And then we have to license it. And that's another scripting language and another process. And then we finally have to create executables that the user can actually use, and that's more documentation and more processes and subunits. And our simple things are not simple. So we have billions of interfaces for every application out there. We have billions of redundant logic because all these applications pretty much perform the same actions. We have very few actions that we actually perform, but it's all manual, it's all redundant. And there's variations in every logic. No two programmers are going to program the same logic identically. Computer technologies are designed to be needed. So if you want to run Word, you have to use Microsoft Word or AutoCAD or all these other products. They're designed that way so that you have to use that product. And documentation is required in all these products. How do you run AutoCAD? How do you create a circle? How do you edit in Word? How do you create a label in Word? Excel, how do you create pivot tables? Documentation, which means redundant logic, if you're going to apply it to your information that you're trying to share, somebody has to say, well, here's a pivot table description. Well, now somebody has to reproduce that pivot table logic, which is almost impossible to do. And then it's going to be prone to errors because it is impossible to duplicate logic, and we have different interpretations of documentation. So sharing is a manual programming process, which is prone to errors. This is why information sharing is a difficult or impossible task. And so it comes down to lack of programming talent and knowledge. This is not really on the person or the programmer. This is on the backs of our technology. Our technology does not give us any help in this area. And then, of course, we have different versions of the same structures and the same logic that don't apply. So, I have a 2003 version of Word, and I can't open the latest ones. So versions kill us on information sharing, even within the same products, within the same structures. So sharing between what? So what do I mean by sharing? I jump over a lot of knowledge that I know, and you'll think, well, he's just talking about, creating a CSV or something. No, that's part of it. But really, what are we trying to share between? So we're trying to share between applications. So it's impossible to share between any two applications. So we have client server. So I have the client over here, a bunch of clients sending off to a server to produce an action. So this is communication or sharing of information. I have a command string or something I describe. So we're sharing information, whether it's a scripting language or a batch process language or an install language or whatever, or a run this execution, run this SQL, run all of these things are client server, and so we're trying to share the information on the action request along with the information that's returned by the server, and then we have to realize what it's producing for us, and then we have to input that information into a structure. So our databases are sharing between the client and the server. Same way with cloud services. Okay, I have something out there, it's on a different machine. So this is what I'm sharing. I'm sharing between the client and the server. I'm sharing it between my application and the file system. I have to somehow this is almost impossible. I have to get my information out of memory and save it. Well, we don't really do that. We might save a billion different ways. Every version is going to be different. We may do a memory dump and then load that memory dump back in, but that's not really shareable because only that one application knows what those bytes mean. And so we might share with our operating system how many processes are running, and so on. And we share with our database, our hardware, a mouse click. Share the information from the mouse click. How do I know where the X and Y is? How do I know what button was clicked? And so on. And so all of this information is actually information sharing. We don't think of it that way, but it truly is. And if we can solve these and eliminate our dependencies on our databases, our client server, clouds, file systems, operating system, and our hardware, which is, can we actually control our hardware without any work? Right now it takes months and months, years and years to implement any of these simple operations of sharing with ourselves. So like I said, we share with hardware. Okay, our mouse, our memory, our keyboard, our monitors, our network, all of these things need to be shared. So I need to know how to get to memory. What's in memory? What's that information? And what's our keyboard going to send us? How do I get to the monitors? How do I get to the operating system? So on. Between subsystems in our own system, we may have a subsystem for editing, and then one for processing, one for accountability, and so on and so on. And we have to share information between those subsystems. We do this in programming, which is extremely difficult and extremely time consuming. And then we share between our applications and hardware. So we have a communication there of information that's going back and forth. And then we have communication between our functions. This is extremely difficult because it's all human based. Oh, I'll write a function and the first parameter will be name, the next one will be ID or something. And so we put the human in there to look through the code to determine, or documentation or whatever. And then the interpretation of that sharing could be assumptions. I know I worked 2 weeks just trying to delete a virtual directory from IIS because the documents, I created them, I renamed them, I did all kinds of things with virtual directories, but I could not get the delete function to work. I finally found 4 applications in China that actually used that function, and I could see how it was applied, and I finally got it to work. But these are the things that documentation doesn't give us. How do we accomplish sharing and applying the information that we do get to an action? And so we do it between storage and our applications, so our file systems and all of our devices. And how do we know what it's sending us back? A lot of this is through our operating system, our file system. So we have our file system, and then we have the hardware device itself. And so there's a lot of information moving around that we're sharing. We don't think of it as sharing. We're thinking, oh, that's just processing, that's just programming. But in actuality, it's not. It's actually sharing of information, getting it from point A to point B so that a particular application, part of an application, can use that information. Really, information requires identical logic at all locations. Even if I get it, I have to know, I have to have the knowledge to use that. And that's what we're missing. We hard code this in our source code. And so when we share information, we don't give that information up. We don't know that it has to be 2 bytes. We might tell it, okay, it's 2 bytes. Okay, are they flipped? What is the order of the bytes? We're not getting that information. We're making assumptions. And so this is why 90% of our failures are simply in our lack of knowledge on the use, domain, structure, substructures, and purpose of any piece of information. Information requires all dependent logic and hardware at all locations. So if I'm going to share something, I need to get all dependent logic. So I may want to share Fahrenheit and Kelvin. Well, if I can't convert those two, that requires a function. If I can't have that logic where I'm sending the information, then we're not really sharing. We have to get complete logic. So if I have a code table, let's say 35 means that this is a x86 hardware CPU, an instruction set. Well, I need to know that. And so all the code tables have to go. So this whole concept of sharing is a lot more complicated than just name, value, data type, length. Sharing, that's not sharing. That's just giving you a value. Here's a value. You do with what you want. But that's not sharing. And it should be independent of time. And it should be independent of location. So if I send something over to England, then I have to really share the information that these are in feet per second or miles per hour, and either convert it for them or make sure that they understand that what units it's in and all the variations of that. Now, sharing what information? So we want to share what's in the application's memory. Information that's in a remote application's memory. So we may have multiple cores or multiple machines, and I need to know, what state that particular process is in, or a billion other pieces of information. Information from a hardware device. How do I know what operations that hardware device can actually do? If it's a stepper motor, I need to know what kind of stepper motor, what it means, how many clicks, how many degrees per click, and all of, how many monitors. Our monitors, we can't even tell the size of a pixel because that information is not given to us. That information is not available. So we have to be able to get all this information from our hardware devices. That's sharing. Derivable information, okay? Because some processes can derive information. It's like, I'd like to be able to share, when something was created. Now, that may have been given and we have the information, but it has to be derived, which means it has to go out and either somehow calculate it or get it from a remote site or give it from memory or have that process of information accessibility be derived. So when we do share it, it's also derivable. all binary structures. We want access to every binary structure out there. Executables, AutoCAD files. We'd like to share this information. All documents. So every PDF and PostScript file and RTF and ASCII and Unicode and all these stupid variations, we need access to all that information in the form with intelligence so that we can actually process it and reproduce it exactly. All programming scripts, so whether it's in Fortran or Cobalt or C Sharp or R or Go or Python, or we need to be able to derive or process that information. That would be sharing, which means our logic is already there. It can be applied to all of our scripts, all of our install scripts, all of our make scripts, all of our compile scripts. All of these things need to be, and we should have one language to do that. But this is what we're trying to share. We can't just have these separate applications just doing each one of these steps. It has to be accessible by everybody. To have shareable information. What does it mean to have shareable information? Well, it must have a purpose. If I'm going to share it, then it has to have a purpose. It has to have some purpose that is known. It's graphics. Okay, I can draw it, and it's music. I can process that. So it has to have a purpose. And it also must be application, operating system, and hardware independent. So if it's not, how do I overcome those limitations? It's not shareable, really. You have to be able to. This is what we're trying to get to. We need to get our information in a process that's actually independent of the application. We take everything out that isn't logic out of the application. And if the application needs to know something about the information, like how many bits or whatever, that has to be in the information itself, not in the application. That's what we're putting in now. We put all these data structures in our application. That's wrong. That's where we went wrong, and that's why none of our information that we have now is of any value in shareability. And it should be self-knowledgeable, which is what I'm saying. It knows the domain. This can be changed. This is changed at this location. It can't be, if I share my application's data, let's have a map and I'm looking at it on the screen and we're sharing it, and you make changes, those changes have to be applied to my application immediately or sometime. And that it has to be transparent. So there is no logic required by my application that is not performed by your application. And it should be automated and bi-directional, which means that it has to go both ways. Right now, we can't move our information out of our own applications out to disk and back in without a lot of work. We can't really do it. It must be forward and backward compatible. It means over time that independent of what you do, your information must be compatible with your own program. If it's not, then it's not going to be compatible to anybody else's program. That's why we got to get to this point. Hard-coded into to not be forward or backward, then it's not really shareable because it's version dependent, time dependent, location dependent. It must be universal. The logic and the process has to be identical everywhere. So the solution, which is to design all information and logic to be shared, period. This is what we need to go to. This implies one infinitely large application. I like to call the assistant, which means he knows how to manage all information before we get the information. And it should be accumulative, so we don't have to start extremely large or infinitely large. We can start with zero, with nothing in it. No logic, no information, nothing. But as we add each information, the system has to account for it. Like a library system, we build the library, we build the cataloging system before we get our first book. But once we get our first book, We know exactly what shelf it goes on. We know exactly where it is. We know how to catalog it. We know how to classify it. This is the whole process of the solution to share information and logic. And we need to get to one computer language, all powerful, that it can do music and magic and physics and mathematics and everything, and all the scripting languages. And we don't need billions of independent applications. We need one application that dynamically or statically loads in accounting. So if you're only doing accounting, you don't need an infinitely large application. You just need the accounting part of it. And that's all dependent on the size of your business. If you have 2 employees, you don't need the whole accounting system. If you have 1 billion employees, it's different than 100,000. And so everything, and it depends on where your company works and how many departments, and all of these things are qualifiable. So, and it should be, like I say, cumulative logic and information. So as we get more, it's all managed and maintained and shareable into every application that's created, or you want to share with, or a computer or person that you want to share the information with doesn't have the logic required. Then we have to be able to share that logic too. So that if you have a special map of a molecule or something, and you got 4,000 lines of special logic, that needs to go with it, so that the user can just open it up and it runs and useful to that client with no work. We need one editor. So we need one document for all technologies, like I said, and user-definable display characters and symbology, so that nothing is static. Everything is dynamic, so that if he's a mathematician and he comes up with some process and he wants to use a special symbol for that, then that needs to be put in the document. And anybody that opens it, it's visible and functional. So it means to check if this is inside that, or if it's a set or subset of something. That all logic has to be applied. And we need computer definable actions request language. Not everything can be assumed. Pre-assumed means that I don't know exactly what you're going to do, but the user does. So if he's only working, let's say he's doing procurement. I was working with Lockheed Martin, and they were doing a procurement system, and they hated it. It was a great little system, don't get me wrong. They did a really nice job on it, but it was slow. It was very cumbersome to the user, to the end user, because it was massive, and they were trying to send people to the Antarctic, and they were buying all the equipment for, I think, 120 employees or something that were going to go down there. So they had to buy these gloves and all the equipment that everyone needed, and the gloves alone were like $1,500. If they could have customized their context a little bit more, then their sharing of information would have been extremely more efficient. And we need common fake authoritative lists. Authoritative lists are extremely difficult. It's almost impossible to say, here's a list of all boys' names. Is it always up to date? Never. Is it precise? Never. Is it? So that's why I say fake. But we could use these things we have lists of billions of pieces of information, all the scientific names for systems and cities and states and countries and artwork, and billions of these lists of information. We can't really get an authoritative list, but we could get close enough that it would be useful. And that's what AI is doing. Oh, we'll go out and find all these lists of things. You can't really, but you could, because all this information is not available or understandable. And the more AI comes out, the less and less people are going to want their list available to processes. Move all information out of the application source code. So we hard code in everything about all of our information all into just a name value technology. This does not work. This is why none of our information is shareable. This is why we have to have one application for each data structure, and that's all we can have. What if knowledge cannot be shared? What's the result of that? Well, we kind of see it now, but it will be the end of all technology, literally. If we can't share information, means that we can't share or logic, that our technologies are pretty much stagnant. We cannot do mathematics right now because our editors cannot put in mathematics. We can screw around with our keyboard. We don't have enough character. We don't have a divide symbol. We don't have an integral symbol. We don't have fractions. We don't have units. We don't have, and that's only a very, very small part of our technology. We have limited it almost to what we had with our key punch. I could write all the programs I'm writing now on a key punch. So no alternate views of the problem. So we have no progress. So if we can't share information, means that I can't see what you did and exactly how you did it, then I cannot improve it. And if I can't improve it, even if it's myself, means that, which is where we're kind of stuck at now, we can't change any of our software. We have software 60 and 80 years old that we can't modify. So knowledge will be controlled by someone else. That's what we're saying. So somebody else created this application, put in his or her personal preferences, did his best knowledge at the time that he wrote it, and then my assumptions on is it valid, and we can't even tell if it's valid. There would be a price for knowledge. Means that if we can't share it, then how do we create knowledge? How do we incorporate more knowledge into ours? Well, it costs us. Every time we write an application, we have to go back to the basics. We have to put all the knowledge that somebody else knows. How do we convert Kelvin to Fahrenheit? Well, how do we calculate Easter? All of these things? It's a huge price. And the quality of life will be lower. So if we can't progress or create new technologies instantly without relying on the computer technology, then we're not getting anywhere. So with AI and all these things, it will take centuries to create any new application. Right now, it takes decades to create a new application. If I want to create a new operating system, that should take a few minutes. But right now, and the more we progress with all these more layers, more AI structures and substructures, and using the same technology that we already have and cannot share information, then it's just going to get harder and harder to create our applications. So what if information could be shared? So I want every technology to progress independently. So we're not relying. I've waited 80 years for a decent compiler. It ain't happening. I could have been using Fortran this whole time. It doesn't matter. We're saying, well, we have all these, but they're not any better. They're just polish on the same technology. They're just fancy assemblers. Less typing, but that's all it does. It doesn't reduce the logic or the amount of work that I have to do in my application. It just does less typing. And typing is never the issue, or it's never been an issue. And we want users to control their information in their own hardware. So you create information, you would like access and be able to do anything you want to. If you want to use a different product on it, then that's what we need to be able to do. I spent 25 years moving maps around. I was in mapping, and so I was good at doing binary access of all these mapping systems. So I did about 40 mapping systems for about 200 clients. They were stuck on these mapping systems like Centercom and Intergraph and ProScan and GeoVision and Small World and billions of these little, mapping systems for cities, utility companies, but cadastral mapping, which are the parcel mapping, tax maps, governments, electric utilities, oil companies, everybody that had mapping at the time were stuck in these older systems, and they needed to be able to go to the newer systems so that they could share information. What we found is that we cannot share maps without going to one common system, and most of those were Esri at the time. Probably still is, but well, I won't go there. But they would pay me to get all their information out and move it. And all these companies, vendors of the mapping systems, would not publish their internal structures. So I had to go in and dump, and I'd spend 6 to 8 months dumping their information and finally getting it out. And I did a lot for CableCAD and all these structures, which were, extremely difficult, very valuable, because they spent 10 to 20 and 30 years creating these maps, and parcel maps. It takes half an hour to resolve each parcel, and they may have 1 million and a half records, or 1 million and a half parcels, like Harris County, which is the Houston area. And so I did a lot of these maps. But the more they can access their own information, the better, because they can run other processes. They're not relying upon the mapping system or the structure or Word. How do I create a label? I hate creating a label. Pivot table. These are all good processes. I'm not saying anything about it, but we could do more with our own technologies, our own information. Price of software should go to zero. Right now, if you can only use one, they can set the price of whatever they want. Zero wasted effort. So we're not worried about sharing it or sending it to anybody or mailing it to anybody. My sister emailed me an image of a recipe she wanted me to see. She's on an iPhone, and she sent me a HAIC file. Couldn't open it. And it said, well, Windows says, well, go to Photo and open it, and then it'll ask to install the visualizer. And I did that, and it says, oh, well, that's 99 cents. I said, screw that, and I wasn't even sure it was going to work. So anyway, our whole world is built around non-shareability or charging for access to your own information. And we should have one environment. And right now we have 20 billion trillion applications that require manual intervention every time you want to try to accomplish anything. So my conclusion. So the current computer technology trend is that one that restricts every user's access to his own information and gives control of the hardware, communications, and security to the makers of the hardware and software. So our cars, our TVs, our phones, our doorbells, ships, planes, everything is controlled by the hardware without any of our input. I fear AI will just give more control to the hardware and software companies with less control than we have now. I fear using AI, there will be a greater chance of computer failures and more worldwide outages. At a minimum, there will be more cost to use computers with less access to knowledge and to logic. So we're not moving forward, we're moving back, we're moving deeper into less control and less access. But by allowing everyone to have the ability to access and share information and logic, will give each user control and access to the information and control of the hardware that they own. So I hope in the future that we can buy the hardware and install our own software. No one is going to tell us or control our security or access to our own information, which is ridiculous. This is what bothers me, is we create a document, and the only way to look at it is from the editor that we use to look at it. This is why sharing of information and logic is so critical, and we're really on the wrong track, and we should move forward into a world where we have access to everything. Finally, my solution to information sharing and logic sharing, I kind of call it the assistant. Do we call it a compiler? Do we call it an operating system? Do we call it our application? So I won't. We'll look at what we want to do with information. We want the sharing of information and logic as one system. It is one system, and it's the assistant or whoever you ask for information and logic. This is transparent to the developer and to the user. It's accessible to the user and the developer, so that all information that the developer creates is organized and cataloged and ready for acceptance for application development, and to the user, his or her own context. And so the interchange of information, the sharing of logic and information is handled by the assistant. So it's one system. There is no difference for the assistant to get any information in its proper form for any exchange between functions or devices, applications, memory, storage, subsystems. So if you have two subsystems in an application, you're actually exchanging information and logic, and that's all handled for us. And between computers. So every computer in the world is completely handled as one system. And so we look at cores and processes and threads and cloud services and client servers and databases and every binary structure out there is information. And the retrieval and storage of all of this is handled for us. So we eliminate all of this work from our applications. So we have all of our documents. So we have PDFs and Word documents or whatever it is, documentation, books, charts, whatever. We still handle it under one request. And so we have scripting languages, all of our compiler languages, all of our batch file processing, JCL and DOS and billions of scripting languages. We've got, G-code and all of these CNC, and we have billions of scripting languages which are actually simply action requests. Our assembler languages is an action request. Add these two numbers, move memory from here to here. These are action requests, and so go to the store and buy some bread. That's an action request. Create me a compiler like JavaScript with a go-to statement. All of these are simple action requests. A button. Put me a button to pull up a form to create me a compiler or an operating system and this information that we're dealing with is always in context. If you're dealing with an application, it knows it's an application and it knows what it can and cannot accomplish. All information is knowledgeable, means it knows its purpose, its relationship, its organization, and the logic that can or cannot be applied. And it's optimized and qualifiable logic and information handling, so that if you one day come in and say, well, we had it in this context and we were using this particular sort device, or we need a human intervention at this point in our process, say operations or sales or whatever, all application development for the user is reduced to a simple action request. In this case, do this. So this is the solution: is eliminate all the work required to share information. Treat it as one process, not as a hard-coded logic within your application of what the information is, how to retrieve it, independent of what it is. Function to function, we need to get to the point where we treat functions as simply an action request. which it is, and we're sending it information, we're sharing information about the parameters and values that we need to accomplish whatever it does, and then we're going to get values back. So so if we think of it, it is actually a client server request. Same way with memory and storage and all of these other attributes. So this is my solution. We don't have to worry about sharing information. It's already done for us.